all of the presenters will have 15 minutes, from 15 minutes to 20 minutes, and after we will have a short discussion. I think that the best is after each presentation to have a round of questions if they are. And finally we will close with a general round session if we have more questions. So first I would like to invite you to Wlodek Kulesa, and he will present us the session entitled Distance Education and Labs from the Internet of Things perspective. So thank you, Wlodek, for coming here, and it's your time. Thank you.
Okay, just checking if everything is working. Do you hear me? I hope. So thank you, Javier, for presentation and for inviting me for this, let's say, short introduction and so on. So when we discuss about distance education and labs, I think that the map that you can see on the screen is quite important about the distance, because at distance we measure in kilometers, and when you see the map of Sweden, you understand why distance is very crucial in Swedish education system. And not only distance, because when you see Karlskrona, which is very southern part of Sweden, and Blekinge is the smallest region around the Karlskrona, and you see Kiruna, which is maybe most richer as well, because they have a lot of steel, and this is really, but very tough climate and so on. So this is Sweden. This is one issue of the distance education in Sweden, the distance. And another issue is population, because when you see the distance and you see that the number of Swedes is less than 10 millions, is about 9 millions, you can foresee the density of population in Sweden. It means that it's really few people in the north. Most of people live in Stockholm, Göteborg and Malmö, the biggest cities. So I am from middle-sized city in Sweden, and middle-sized city in Sweden means 60,000 inhabitants. So probably in Spain or some other countries, this is just maybe bigger village or whatever. So this is medium-sized city in Sweden. So I work in Blekinge Institute of Technology for 10 years before I live in Kalmar. And map you can see the Kalmar is not so far away. And this is another issue why I am working in Karlskrona and why distance education is important in Sweden. Because in general, there are not so many students who want to study engineering in Sweden. It is why they move or they close education, engineering education in Kalmar, and they move us to Karlskrona. So this was quite important issue. So in Sweden in general, we try to figure out how to motivate people to study engineering, because we need engineers in Sweden. It's a huge country, very industrialized, but we don't have really Swedish people who want to study engineering. We have, of course, international students from many countries, but still we want to have Swedish students. So distance education was one of the solutions. So we could, let's say, motivate people who don't like to move from Kiruna to Gävle or to Uppsala to study engineering. This is one issue. Another issue, it is that many people in Sweden, in some, let's say, at some age, after 5-10 years of industrial experiences, they want to continue their education, but they have families, they have some, let's say, life, and they don't like to move. So it is why distance education was very in focus of government issue to, let's say, let it easier to study on distance. So this is why distance education in Sweden is very important. And in the title I put, of course, labs, because maybe some of you know that the Visir system was developed in Karlskrona or Ronneby, because there were two cities. So I think that Karlskrona and the place that where I'm from is in some way in the net of this distance lab, and now we are so happy that this distance lab and visual system is used so widely, not only in Europe, but now we already sold some system to South America and so on. So this is quite interesting that the distance lab is also very close related to the place that I am from. And IoT perspective. This is maybe on next slide you can see more about me, because I am working in a department of applied signal processing, and I am professor in multi-sensor system. And it means from very beginning I dealt very much with wireless sensor network. And this is why Internet of Things is very close to my interest. It is just different name, but when we say multi-sensor system and network, it is more or less the same, just the name is a new one and so on. So that we can discuss later how much we need the new names and so on. And because I am a, let's say, researcher in multi-sensor system and in measurement instrumentation, but I have quite much of education duties. So my main courses, those are research methodology for engineers, and the course is given twice a year for master student in electrical engineering and mechanical engineering, mostly related to mechatronics, but also the course is compulsory for PhD students. So master students, they take the course just before the final thesis to know how to write the thesis. So this is something what I help them, because I always say, we engineers, we love to develop new things, but we hate to write reports. So I like to help them to show how to write the reports in the easiest way. I say, I know, I cannot convince you that writing report is funny, is boring, but we have to do it, so learn how to do it in the easiest way. So this is the motto of the course, and I think that they are very happy. And my colleagues, my teachers, other teachers, they are very happy because they think that after the course, they don't need to spend any longer so much time on showing how to approach the problem, how to structure the report and so on. So this is why, let's say, the course is very popular and also among students and among the teachers as well. And I also give the course in sensors and actuators. So this, the last name of the course that I gave in spring this year, is really related to definition of the things. If we look of what is IoT, what is Internet of Things, so we can say that it's cyber physical system. But what are the things in this name? So you can find that the things are the mixture of hardware, software, data, and services. So, and the aim of this IoT is to monitor and control using sensors, actuators, and network. That's all. So we have sensors, we have actuators, and we use some connections between those and so on. So I was so happy today because I had opportunity to visit your lovely lab in Düsseldorf, and I noticed that you work with Visor very much, but you also use Internet of Things in the sense that you use the control system and you have the robots and so on. So this was really something what I said, oh, it's okay because they will not complain that I try to introduce a new idea and I want to abandon some old idea. I think that this must be something really mixed. So we shouldn't focus on only one solution, but we have to search for new solutions as well. But we can have that this idea has, let's say, very big advantage because in some way it is a democracy in network because we can have access to data. It is not only that rich people, they keep this data and they have good laboratories and the others, they may not have access to this one. So I think that democracy is very important issue in this IoT. So this is my idea when I thought about this presentation. I tried to find some advantages and disadvantages. So I thought that this is one of the biggest advantages, that it democratizes in some way work. We live in global village, but still we have, let's say, disproportion between people to have access to different resources and so on. So I think that this is... We use the same sentence. Do you? Okay, fantastic. Not physical, but to labs. Yeah, but labs is a physical labs, because it is not just, artificial, virtual and so on. But of course there are some drawbacks as well, because in general there is no any standardization. My background is measurement instrumentation, so we search always for standardization. And here we still suffer of lack of standardization. The same with Visor, which became some kind of standard, but still there is no one standard. This is also in internet and all technologies that we use, wireless technologies, is also the problem of need of standardization. So this was about, and when we discuss about distance engineering education, because this is not distance education, this is distance engineering education. What is the keywords? Engineering is here keywords, because distance education in maybe some humanistic sciences or our sciences, it could be quite simple. But engineering, it means to have access to physical world. So this is something what requires different understanding what is distance education for engineers. So we say anytime, anywhere. This is what the young people love, because the young people, I was young the same a long time ago, so I don't remember it was the same, but young people don't like calendars, they don't like schedules. They want to work anytime, anywhere, when they is convenient for them. So I think that this education is suitable for people who may have some little problems with time management. Because with this access anytime, anywhere, it is a little bit more easy to do it. So it creates, of course, a lot of opportunities, because you can work whenever you want and so on. But of course, there is also some threats, some drawbacks, because engineers, we also need scheduling, because when you work in industry, they ask you to follow the schedules. So this is something, let's say, how to find the balance between the freedom and need of education to handle the time management. So I think that this is one of the issues when we discuss about distance engineering, how to manage this both, let's say, opposite the poles of education in engineering. So this was what I think that was important from my point of view. And now when I thought about this presentation, I know what I want to present, but I try to find some philosophy of, let's say, today paradigm of a remote lab, which I call that is more center-oriented. It means that we have lab and the people around can access this lab. So this is quite interesting, because maybe this is a cheaper one, because we can have, let's say, less equipment, and access to equipment is very democratic. Anyone can have this access. So this is the paradigm that we use now in Visor and so on. So this is something what I think that is quite good implemented, and it works pretty well. And of course, it provides also opportunity for networking and standardization, because we have to adjust to existing standards. We cannot create new standard in networking and so on. And also this kind of approach provide the students opportunity to develop their skills, but they are more virtual skills. This is what they can operate using computer, mouse, and so on. So this is more virtual skills than manual skills, because I am engineer, and I think that manual skills are very important. So when I was in your lab today, and I have seen the solder station, I said, oh, this is real engineering, because when I don't see solder station in lab, I think, oh, take it. So this is not engineering, because engineers should know how to solve cable, how to use the cable, and so on. So for me, manual skills are very important. So let's say this remote lab really helps students to develop their virtual skills, understanding, manipulating, and so on. But still, there is some lack of what engineers love, touching. If I can touch something, when I see what is IC and so on, is quite different. So I think this IoT create a new paradigm, which I call future paradigm, but maybe it's not future, but it's already existing, home lab. This is something what I will show you the case study of my course in sensors and actuators. Engineers love experiments. If you a real engineer, you need to do something, you need to operate with. If you are not computer engineer, but I don't think that we have any computer engineers here, but more or less electrical engineers, they like really real stuff. So when I told you that engineers, we don't like the reporting, we don't like, let's say, paperwork, and students in Sweden, on the first year students, the biggest problem is to study mathematics. I want to do something in lab. I want to do in mechanical labs or electrical labs, and because I came to university to study engineering, not to study mathematics. So, and after half a year, I don't know, 20% of students, they quit because they think, okay, this is not what I thought that is engineering, because after half year, they don't have real access to laboratories and so on. So this is something what is scaring for them, because they think, oh, I took a wrong decision. So, and in engineering, we learn by try and error. There is no different way. If you design whatever, is always something what is wrong. You have to change, you have to try. This is principle of any experimental and so on. But nowadays, we have so cheap access to electronics, to microcontroller. And this microcontroller, which we use in sensors and actuators, is Arduino. And this, I found some cheap learning kits for Arduino, 23 euro. This is no money almost. It's so cheap. And when we designed this lab or project in sensors and actuators, there was from very beginning Arduino, because I had before the final thesis in companies and they use Raspberry Pi and so on, so it's a little bit more expensive. So we search for something what is democratic, cheap. And I can buy it or I can rent it from university for the study period, for maybe project group or individually, and I can develop it. You have these robots, Arduino robots and so on. So, but students, they love to have this robot at home already. And this is not very expensive. Maybe for different countries, for different people, but at least in Sweden, it's not expensive, because when you say 23 euro, it's just maybe one big dinner or whatever. So this is still in the students', let's say, budget. So it's not above budget and so on. So I thought that the new paradigm is to have this laboratory at home. But it doesn't mean that we should skip this centralized laboratory when you can have more sophisticated experiment and so on. But to do it parallel. On one hand, we have this centralized, and on the other hand, we have this decentralized labs using Arduino and so on. So this is what I think was my idea, and I see that I am coming out of time. And just two last slides about course study. There was course with 4.5 ECTS. It was problem oriented, and students, they love it. Some system. This course, I met them again in the research methodology course, and they wanted to continue Arduino project. So this was something what is really interesting. This is the photo from their project. They had some pulse measurement. They have even this 3D printer, and they print this, let's say, plastic issue to make, and we, because in PTH we have quite a lot of medical technology, so we have found some, let's say, application in medical technology. So coming to the conclusions, advancing technology gives us, let's say, possibility to make the education more flexible, adjustable for different level of students, first year students, the last year students, and in terms of schedules, because students can be free, they work when they want and so on. Some students can have part-time job, and in Sweden it's also possible. And it is possible to meet their interest in early curricula, not in the last year and so on, because this is so simple. And they learn so fast because they love it. Okay, thank you. I think that I used my time. Thank you. Thank you.
Thank you, Lord. Maybe you have questions, some of you. Maybe I can make one question, but okay, Gabriel.
Don't you think about the Internet of Things that we can call also Internet of Trends?
Yeah, it can be. You know, Internet, as anything, has two sides, as any coin, positive and negative. So this is also could be scaring sometimes, but you know, you cannot avoid it.
I got the democratization with the Internet of Things because not everybody is going to have access to any data. It depends on the data, it depends on the sensor. It is not so clear, but well, it's not maybe the place to do this.
You are advocatus diaboli here, but it's okay.
My comment is only because I like your presentation.
Okay, thank you, thank you.
More questions? Lodek, now we can say that we don't have only three different kinds of labs. So the classical lab,
Yeah.
plus the simulator, this is not a lab, but it's used instead of, plus the remote lab, plus the lab at home, because what you defend is to take one lab at home. I know that this is popular now in USA. A lot of universities that are teaching on distance, they are sending by mail, by snail mail, not by email, these popular Arduino boards to give the students the opportunity of creating their own projects. So I think that again, it's not about this or this, it's this and this. So why not?
Yeah, also usual.
We are developing a remote lab with Arduino.
Yeah, I'm also happy to see the Arduino in this.
So maybe it's time to go with the next presentation. The next presentation will be, thank you again, Lodek, sorry.
My pleasure.
The next presentation is going to be made by Andre. Andre is coming from Portugal. It's 1 hour less there. You remember, Andre? Yeah, so you are starting at 5:30 in Portugal. It's a joke. Yes. So now is your time, and the presentation will be centered in a project that we are running now. It's the Pillar project. So, Andre, it's your time.
Okay.
Now we have a problem. I think so. Sorry. Please wait a minute.
Okay. User error.
Now it is okay.
Okay. Restarting the presentation because the remote laboratory has the mute activated yet. Okay, from the start. My name is André Fidalgo. I work at the Polytechnic of Porto School of Engineering, researcher and teacher there, and we are working on remote laboratories. In this case, we are working on the Pillar Federation of V0 laboratories. This is going to be the outline of my presentation. I'll try to be not too long, so the next presenter still has some time to do it. And this is Vizier in a nutshell. You need a circuit, you want to test circuits in remote laboratories, you get a breadboard to play with, and instruments to see your results. This comes from BTH, Boeking Institute for Technology, since 2006 in operational mode. This is what we have, the real laboratory where it exists. It looks like this. It uses National Instruments equipment for the measurement, and it will uses a switching matrix for the circuit itself, for the target circuit. The interface, as you've seen in the previous slide, it's supposed to be as realistic as possible, so the students feel they are using a real laboratory. So this is PILAR, or at least these are the PILAR institutions and laboratories. Those 5 institutions are those where we are using Vizier at the moment. We have courses in Vizier and are part of the consortium. There are several institutions outside PILAR that also use Vizier, but at the moment the Federation will be focused on the first 5 institutions and probably increase later. This is just to give you an idea of the number of the users of the Vizier systems, so that we see you already have a good implementation. And this is to give you an idea that there are many languages. This board was used to define what languages you can use the interface in, or we are using the interface in, so we have a vast number of users on different languages. This is one of the issues we have and we are trying to solve with the Federation, is login methodology. Each university has a different system, a different login methodology. Some have guest access users, some have not, but there are ways to interconnect this between institutions. So this is where we are starting in the Federation. We have different systems, different login systems, different physical locations, and we are trying to make this better. What we provide right now is several experiments in several institutions on several courses. Filters, passive filters, Kirchhoff's law, Ohm's law, diodes, transistors and pops, and in some cases logic. As you have seen from the tables, different institutions have different experiments. Some experiments are, for instance, like diodes here, are present on all institutions. And this is a quick example of some other experiments that some institutions have. There are many more or several more. This is just an example of what is available right now. So back to my main point, what is PILAR? What is the PILAR approach? PILAR is an Erasmus Plus European project. It's called what you see there, Platform Integration of Laboratories based on Vizier. So it was, I was trying to explain, and it's part of KA2 call from the Erasmus Plus project. These are the partners, the 5 partners I mentioned before, and 3 other partners that are supporting the project but don't have Vizier at the moment. And this is what we are, the persons we are trying to interest in our approach. Mainly the Vizier laboratory can be used by high schools for teaching basic electronics, universities, in fact any education institution where this can be used. To increase both competences, to perform different experiments, to try simple things many times, or to try complicated things. We will need to address students and teachers of those institutions and give them the necessary knowledge to handle these laboratories and then use them on their institutions. So what are going to be the main activities? The main activities, we are intended to make an integrated platform of the laboratories. We want to make a simple single access solution that you can go to one single place and find there everything that the Federation has. Every circuit, every experiment that it can be shared is going to be, or it's supposed to be, on a single location. You can have several circuits, several experiments, different complexities, some simple, some complicated, everything on the internet, everything on real laboratories. As everything, our institutions have lots of experience, and we know that there are some things here that are very important. One of them is documentation. It is very important to have clear and concise documentation that allows a student or even a teacher to get right at the subject when he wants to, when he can do the experiment, play the experiment, and later perhaps understand it in more detail. These services will be available on different institutions, so it's very important to have some kind of standard documentation that we can provide as an institution, as a federation, sorry. And the idea is then to provide this as a service for local, regional. Every institution in Europe or even in the entire world can use one of the laboratories from the Federation. So the big advantages we think the federation will have is a larger set of practice in the sense that every experiment from every partner can potentially be in the POR federation system, so we can have all a larger set of practice than in each individual institution. It will be more effective and effective. A simple example, you no longer have to have the same experiment in all institutions. You can have divide the experiments by institutions and have a more effective use of the resources, because the resources are always a bit limited, and we can have more experiments like this. We can support all the services on a centralized approach. We can have innovative practical experiments that they are not available at the moment. You can make more complex or more interesting experiments on each of the partners, and we can also control better the students' learning process. How? The idea is to have some scalability. This is the idea is each visit system can support around 50 users at the same time. So if you can have more circuits in different services, you can have more users, or you can have different circuits and not the same circuits, different circuits, and you have more circuits. So you can adapt to whatever you want. Reliability and availability are already very good, but they can be improved. If the number of users increase, this could be an issue. So you can have redundancy in the sense that you have the same experiment in different places, and you also have transparency. From the user standpoint, you will access one single point and get an experiment from one of the federation partners, ideally without even knowing where he is performing the experiment. The experiment is given to him as requested. You can again, this is a real remote lab, so get real results. The students is supposed to get the feeling of being used in a real lab, and you can have a vast set of experiments. Also, the tracking system will be necessary to use also a tracking system to control the accesses, to control who is assessing what, who is performing which experiment, and whenever necessary to include some user balancing. For instance, if you have more users in one system, you move them to another equivalent system, or if this is not possible, establish priorities to decide who can access and who has to wait, and create this system. This project will have several evaluation points. Basically, this is an European project, so it has a lot of numbers, a lot of quantification that will be necessary. The idea is to provide this experiment to the larger number of institutions, students, and with a larger number of experiments that can be done within a controlled environment. Of course, this will require some analysis, surveys to get the opinion from the users, and a lot of support and several material, documented material to support those laboratories. So at the moment, we have several ongoing steps. We are developing the federation. We have to develop policies, cross-user policies, so users can be shared between the different institutions and later on added to the federation. We have created some federation policies on what will be available and when and how to share data between the different partners. This is not an easy task in the days of cloud computing and things like that. It should be easy, but it's not so easy in the real world, real problems. Then we want to make an experiment listing and a list of different experimental pedagogical documentation. What I'm going to show in the next slides is not strategically part of the POR yet. It's something we are doing in Polytechnic of Porto on the idea of making the experiments easier to access from the outside. We have an approach both for students and teachers. So this is in Portuguese. We are still working on Portuguese, but I'm guessing most people here won't have a big problem. So we are trying to find easier to access guides that teachers can easily put into the system. So this is basically each HTML and some figures. So this is just an idea of the theoretical part. This is an interface with a teacher where we are using something called a max list. I will explain that, I think, on the next slide. So basically, it gets a list of what it can use on the circuit and some information on how we can do it. This is specific information for teachers that already have an idea how Visit works, but it's supposed to be easier for them to add experiments using forms and automated tools. This is, in short, this is a bit technical, but this is a max list. Whenever a laboratory is used in Visir, this is the information that is necessary. Not a laboratory, an experiment. This is what says to the machine that can be used, what can be done on that specific experiment. In short, in red, you can see specific components. Shortcuts are tricks to allow some things to be measured. Black box are components that are not known to the user. The idea is to simplify a bit. This is still necessary to make it an experiment, but try to have some kind of editor that allows a teacher to do this easier and then send this. Of course, we don't want to ruin anything on any laboratory, so somebody will have to check this, so to make sure this is okay, but this is supposed to ease the documentation and communication process. And you get, from the administrator point of view, a series of experiments. Bear in mind, this is from the administration point of view. The students will have a much nicer screen, but this is just to give an idea of how complex it can be to manage a set of experiments. This is just in Porto. On a federation, you have a much harder task, but this is the basis of the problem. And the most important part, we think it's very important, is a contact form that allows easy contact to the developer by the teachers or to somebody that can help with a specific problem by a student. So we are adding this as a contact form that should be constantly updated. So the person that is available at that time can be contacted for that specific experiment. So the person, be a student or a teacher, can ask what is wrong if there is a problem, or how can I do this if there is a doubt. And this is it. I hope I didn't spoke too fast, but they told me there was a bit pressure for time. But I'm happy to clear doubts slower if you have some doubts now.
Thank you, Andre. Any question from any of you? It's interesting to see this presentation about the Pilar project and the BC system, because as many of you know, Ingvar passed away 1 month ago, and tomorrow in Karlskrona, in Sweden, they will have... in Stockholm. Okay. They will have a ceremony to honor Ingvar Gustafsson. So I think that is nice. It's hard, but it's nice to see that BC still is running and alive in 2 different projects. And I have one question for you, Andre. Imagine that we have the federation running, and I would like to ask you, what is the main challenge or the main risk during the federation?
I think, personally, I think the main risk is the federation doesn't provide what it offers. So when we have the federation, we should have everything very well structured, so we will provide a very good service, and then we will be looked for, people will be looking for the service if the service is good. There is a big interest on this type of remote laboratories, this type of experiments. So if you provide a good service with reliability, with contact, with documentation, I think this is a very interesting project. Big risk is, of course, if something goes wrong in the communication process, not in the technical process of laboratories, they work, but in the communication process, that can be a problem. That's what I think.
Yeah, because I think that sometimes the teachers are researchers, and we are using BC, the system, as user and researchers, so we mix different roles that they are affecting, not always in the good direction to the service that we offer. So maybe what we need is to have 2 visits in each institution. One static visit with some experiments and some circuits, and another visit for playing and to developing new ideas or new projects and so on. Because I think that what you have said is the main challenge is to maintain the service, not to create the service, but to maintain it in a good condition. So, Andre, thank you very much for your presentation. I don't know how to... Manuel, ¿sabes cómo compartirla? Share aquí. My screen. Vale. Ya le das aquí. A ver, perdóname. Estaba aquí, ¿no? No sé. ¿Cómo lo has visto? ¿Tú lo has visto?
Can you see the slide?
¿Me oís por el...?
Yes. And you can hear me, right?
Microphone is on because I don't know.
Can you hear me? Okay.
Yeah, it's on. It's on, but I didn't remember it. I closed or not.
Okay, so I'm Pablo Duña. Many of you knew me when I was working in Dustotec. Now I still work in those, which is what I'm going to introduce now. Well, just as a matter of vision, as Wladek was presented before, once you're working in a STEM education, you have to choose between expensive advanced labs or in online or massive environments, you need simulations or low-cost devices like the lab at home that he was presenting with Arduino. And the alternative, as he presented, is all these internet accessible laboratories like either simulations or in our case remote laboratories, which in the case of remote laboratories you know very well what it is. Now the holy grail of education labs is, as Andre was presenting in the case of Pilar, is that if you have like 3 laboratories and I have 3 laboratories, together we have 6 laboratories, and that's the kind of the main idea of sharing remote laboratories. However, even if the technology might or might not be developed, we are clearly still not there yet. I mean, there are the number of remote laboratories out there and the number of people actually sharing those laboratories successfully is like, it's very, very different. There are many reasons for that. One of them is actually incentives for providers in terms of, not in terms of sharing, because many people is actually willing to share, but people is not so willing to have some kind of liability for that sharing or doing some more steps that are usually expected by the other side. So this leads to the second point, which is trust for customers. Somebody can be sharing a laboratory in another country, but really if I don't, there's no way I can know actually if it's going to be working or not, or if it's a very reliable laboratory, or what will happen whenever something is broken. So if one laboratory is broken, maybe it takes a month or 2 months or something like that to use it. So for the teachers, it's actually very, very difficult to proceed to access other laboratories. Actually, for example, in one project that we work on, the next lab, which is the next version of the Go Lab project, we have the statistics of which laboratories are not used, and in the first remote laboratories, the number 30 or something on the list. All the others are simulations because they are running all 24/7 and it's guaranteed that they are going to be working. And finally, of course, the user experience sometimes is not so clearly adapted because mainly the remote laboratories come from research background and not from our background. So what so Labsland is a spin-off of the University of Deusto. We were working in the Web Lab Deusto research group for 13 years already. And what our goal is to create a marketplace of real laboratories. When I say marketplace, what I mean is that to connect different providers, different remote laboratory providers with consumers, but also providing all the quality assurance mechanisms to see which laboratories are working more and better and which ones are not so reliable, and so on. For this part, for the developing trust, we have 2 approaches. In the case of the real-time laboratories, in the case of the remote laboratories, what we provide is we keep track of the real availability and provide some reliability. So for example, in our case, we have 1 robot, but we have actually 4 instances of that robot to make sure in 2 different networks, to make sure that even if the network of one place is down, the other one will be working and so on. And there's something else, which is the FAIRED laboratories that I will present now. Here, this is like the second part of the presentation. What we are used to have is this. On the left side, we see the robot laboratory, where you have a robot that can follow a line, and it's a real robot which is running real time. And when the students are using it, they connect to the real laboratory, and they will see the robot in real time running in the circle or not, or doing whatever. However, what we started developing in the last 6 months, I think, was also what we call the FAIR laboratories, which is not a very good term, but we're trying to find another. But no, that one. And I will show you just an example to see one example of this. So if I go here, well, this is in Spanish. here, Javier, if I go to the English version, and I go to the inclined plane, what you can see here is that this is a laboratory from Rex Lab, from Florianópolis, Universidad Federal de Santa Catarina. And in this case, there's like an angle that I can choose, and I can say like 32 degrees. And if I click on the start experiment now, we will see how this plane that it has a red ball here, it goes to the 32 degrees here to this angle, and whenever it reaches 32, it will drop the ball. And here there are 6 blue sensors, which will track exactly in which millisecond the ball was being dropped. And here we see the different distances and in which millisecond it went through each of these sensors. The key thing of this laboratory is that, as it says down, this is at the FERED remote laboratory. What you are seeing is not a real-time laboratory, it's a recording that we did. So what we did was, we took, if there are 90 possible angles, we took 10 recordings of each of them, which took several days, and then we store in the cloud servers all the images of these recordings, and we also store all the data that is generated by the laboratory, and then we provide it as a cloud environment. So actually following the idea of Bloodec, sometimes the students don't want to wait or don't want to have like a queue or some kind of calendar or something like that. This laboratory is running 24/7. It's not going to be broken. We can provide reliability for this case. But of course, this is something that we cannot do in all the laboratories. Like in the case of the robotics, of course, we cannot calculate all the potential programs that can be sent by the user. And also, like in some cases, like for example, on the right side, we have the reactivity laboratory from the University of Queensland, which has like many options, many thousands of options. We have a subset of all the options that it has using this same technology, and it's also available. And on the left side, it's this here, which is again also not possible to create the full data set, we cannot store all the potential measurements that the user can do, especially when you play with the full screen generator or the power supply. So in this case, we might be able to create a subset, but for sure not the whole system. And yeah, so as a summary of the talk, labs and what we provide is like to consumers, which can be schools, universities, and so on. We connect them to real laboratories, either remote or deferred, and to the providers, depending of the laboratory, we provide free services of development of the laboratories. So, for example, in the case of the ones I just presented, where what we do is to connect to those laboratories and create that dataset version. And we also find the consumers for those laboratories so as to be able to monetize how those laboratories, which doesn't need to mean money, it can also be some kind of exchange of services or exchange of access to other laboratories and so on. And yeah, that was the end of the talk. Hopefully I didn't consume too much time.
What is this?
I know that you're sharing the screen, so
what is the stop sharing? Okay. So questions again. Thank you, Pablo, for your presentation. But if you have any questions, I have one question, not for Pablo, but for Bloodec. You have seen the system running. Have you felt that the system was real or not? The inclined plane. It was real? It's real? So the second is that maybe you can find a new word instead of different labs, because we have a long discussion with this. So maybe you can suggest us a new word. We are looking for it. So, because it was in line of my problem, because when I came to the laboratory, I said, oh my gosh, Something there that we have no remote lab.
Well, as you know, I live there, but I remember here, and there I mean, really know what, I mean, probably Manuel can answer much better that question. I only know some examples of this also the ones from Northwestern University, but as I said, I'm not so much in the daily life of universities there, so.
But not in universities, in society in general, institutions, education.
In the case of, let's say, speaking from the more from the Silicon Valley side, as far as I'm concerned, it's not so well known. They know examples in the past, like Labiticon, like for example, like I've heard in different forums talking about this Russian company on remote laboratories, and also especially in simulations, Laughter is very well known, which is the Danish company on simulations. But remote laboratories as a real service provided to customers and so on, I haven't heard of it.
Thank you, Pablo. Thank you for your presentation. Do you have any questions for closing the session? I have one question for one of you, because Isaac Seoane is with us. It's the first time in this kind of webinars. Isaac, are you interested in remote and virtual labs? Yes? No? Why you are here in this session? So please, you can switch on your microphone.
Now he can speak because he have now access.
Isaac, are you there? No?
Okay, it seems that Isaac is not now. Maybe he's trying to switch on the microphone this last time. So thank you very much for attending the webinar or the technical session. Thank you, Oscar, for the technical support. Thank you, Manuel, for the idea, and thank you, of course, to Lodek from ETH, to Pablo from LabLab, and to Andre from IPP. So that's all for us. So see you.
Bye-bye.